welcome. I'm Gopal, as he said. Today I'm going to talk to you about nearline systems. So there's going to be a lot of context that I set about why we need nearline systems to build personalization. We'll talk briefly, actually, about Lambda architecture for some of our recent features. So thanks for setting that context, Sriram. We'll then move to our recent choice to build some of our technologies on top of Spark. All right. So that's my Twitter handle and LinkedIn profile if you're interested in talking to me after the fact about questions. So the obligatory few slides about Netflix, in case you didn't watch it last night. So Netflix is a global streaming product. In case you hadn't heard, we're in about 50 different markets right now and soon to be in all over the world. The recent claim to fame is all the originals that we do, and some of them we launched ahead of time, like yesterday. But otherwise, there's a whole bunch of great content coming in over the course of the year. Netflix is available on 1,000-odd devices. Odds are, if you bought a device, it has Netflix burnt into the chip. And so practically everywhere in the world, even if you're not already there. So about 57, close to 60 million members. By the end of next year, we'll be in every country. So lots of what we're trying to do is how do we build and scale our site and our applications so we can get traffic from all over the world, and how do you manage all of that traffic, and how do you scale the rate of innovation. The famous quotes about Netflix in terms of downstream bandwidth is we consume about a third of the peak bandwidth downstream. What's less known is we consume about 7% of upstream bandwidth. And this talk is going to be about the upstream bandwidth and all the data that we collect and how do we use that, right? So what does my team do? At the end of the day, we live to increase the rate of innovation at Netflix. Innovation, as we measure, is the rate at which we do A/B tests. So if there are two people sitting side by side, their Netflix experience is just a tad different because you get a slightly different algorithm, you get a slightly different UI, the next person gets a slightly different rate at which we send you emails. So every aspect is A/B tested. And how do we keep our heads straight? That's really the challenge, because there isn't one Netflix. There is practically millions of versions of Netflix, not only when you look at the personalized data, but practically in terms of all the combinations of A/B tests that are around. So we try and execute the A/B tests themselves. A subset of us, we also focus on lots of the data infrastructure that powers lots of the data that's necessary for the algorithms itself. So we'll get to that. So the part that people may not realize is every aspect of Netflix is personalized. If you said, hey, you're watching a set of movies, on some devices, we'd show that to you in reverse chronological order. But in others, we may rank the videos that you watched in a personalized rank for you. If you added videos to your queue that we recently rebranded to be My List, the videos are personalized for you. You picked the videos, but they are sorted in a personalized way. That's popular on Netflix, apparently in my home. And so since my mother-in-law watches some Indian stuff, that's there. But that's not popular for everybody. So we take all the videos that are getting played and we break them into clusters of users, probably about 2,000 clusters or something, and I get assigned to multiple of those clusters. And then this is the merged popularity across those. If you take, because you watched Pokemon, that's because my son's watching that, then you have here are the titles that others watched when after watching Pokemon, right? And you can take that and say, yep, there's shades of personalization in that. And say search, right? And search as well is, of course, we need to personalize for the purpose of relevance, but we're starting to get into aspects where if you type BR and I type BR, our intentions may be very different, and we look at past history. So data is basically the biggest underpinning for lots of what we do. So that sets the context. So if you come in and start using the Netflix app, for us to give every aspect of that experience and stitch that all together in a relatively correct way, if we had to do all of that real time, it would practically take us about 10 to 15 seconds, right? Because that's how much compute goes on through the 300 microservices that we run to assemble. And that's basically untenable because the users won't necessarily wait that long for us to give the recommendations. So that's where we start to get into the Lambda architecture piece, because you can't quite do everything in real time. You need to get to do something in batches and get to do some things in real time, and you have to figure out how to merge the two aspects together. So the proverbial, how does data flow, right? We send a list of recommendations to the user, and the device, the user sees it on the device or the browser, and we collect data from the device, and we have a separate API server in AWS Cloud that collects all of that telemetry. We ship that into Hadoop, and our method of choice is lots of Hive jobs to run that ETL processing, saying you did a play, you gave us a 4-star rating. We take that, we summarize that, right? Typically in batches, saying we can't, at the time the user comes, we can't say how many star ratings for across all users, etc. Some of them very amenable to, say, a Cassandra query, but others you just can't, because there's historical data for too many users that we need to aggregate. So then we take that, batch that in, do a batch job in ETL, then somehow take that data, pop it into a memcache cluster. EVcache is the memcache optimized for AWS that's been developed within our team. We use that to say, push a lot of data, and then when the user comes, whether it's nearline or batch, we can say, get the data of S3 or memcache or Cassandra. All three relatively fast, but we certainly don't touch Hadoop in that part of the world. So what kinds of inputs do we collect? And it's, of course, the play input, right? You just told us you played Orange is the New Black. That's important for us to know. How long did you watch? How many times did you pause? And all of that stuff. And another obvious one is you gave House of Cards 5-star. That's a useful bit of signal. Other useful bits of signals are the user tells us their taste preference, saying, I like comedy, I don't like horror. Some of the newer ones we had to introduce over the course of the year, over the course of the last year, is inputs from our users just as they're joining Netflix. Netflix gets better as you use it, but the challenge is we are increasingly in newer markets, and most of our users in those markets are new, right? So we can start personalizing for the user the moment they hit one play. The first play, we can start to say, oh, I think we know something about you, and it's just going to get better. So how can we do something better than one play? Can we do 0 plays? So then we have to ask them, what have you seen before you joined Netflix? Just tell us something, right? And for that, we ask the user for virtual plays, saying, just as you signed up, tell us what you liked, right? And we can then start to treat those as virtual plays, and then as the user starts to give us real plays, we can start to merge those two together and then wean ourselves off these virtual plays. Because people may say, I love Schindler's List, in which case we'll start to personalize based on Schindler's List. But for most people, that's an aspirational title. Because yes, I think I'll be a better person because I watched Schindler's List. But really, I'm interested in Badass 3 or something like that, right? So what we're really, this is back to that circle where we collect the data, we do batching, and we route it, right? And we've talked about two types of data, explicit, right? That's the ones that's so far, plays, star ratings, etc. And now we're increasingly starting to do what's called implicit. Implicit is when the user doesn't necessarily tell us, oh, I'm going to use the site and I'm going to mull over my selection for 15 minutes, right? How long you pause, how you navigate through that site is increasingly what we are starting to do. And that's the piece that's growing, and that's the piece that's very much contributing towards that 7% of upstream bandwidth. And that's critically important to us as we start to look for newer and newer signals that improve our personalization. So the obvious ones are second order of the explicit data. So if you collect raw data, then you can do summing and other aggregates, and you can build popularity. You can then take all the popularity data across all users, and then you can do clustering. You can do all of these kinds of things in Hadoop, right? So that's all pretty traditional stuff. So then really it comes down to why bother with nearline systems? As I said, if you wanted to do everything in the last minute, it takes 10, 12 seconds for us to compute recommendations, and that's too slow. So we need to do a first order batch, which is somehow we can say the first 8 seconds out of that, say assembling the home page, let's do that before the user comes in. So you have to overcompute the results. And because Netflix is in AWS and we go with reserved AWS capacity, we can say, oh, at nighttime we have spare capacity in our EC2 instances, so the API servers are less busy. They give up their instances to the standard pool, and the compute engine starts to pick that up, and we can compute those recommendations at, say, 3 a.m. It also improves our availability story, because at runtime, we're doing less stuff. Less stuff means fewer things can go wrong. And at the biggest one is it allows us to, once you start to do this separation, your algorithms can suddenly become insanely more complex just so you can try it out. And if you try it out, maybe something will, if something clicks, then you figure out how do you optimize the performance. So where we are getting to with nearline systems is, what we're trying to do is let's get to pre-computing the results, which means this is like a huge domino chain, right? 60 million users and all explicit events, star ratings, plays, and so on. And all of those, there is a giant engine. This is Manhattan. This is our internal keyword. Has nothing to do with the Cassandra Manhattan that he referenced, which, of course, this system happens to use Cassandra as well, just to make the system very confusing. We have, it's essentially a giant workflow with 60 million users and all their events. And we can compute recommendations that's constantly humming. And the output of that is lots of the clustering, lots of the similarity selection, and all of that stuff, right? So how can we improve this even further? So the user told us explicitly what he wants. We now need to ask the user, we need to observe what the user is doing throughout his activity. So let's say the app started. Which profile did you select? You went into the home page and you swiped through one row and you scrolled 10 times. You swiped 3 rows. Imagine the amount of data that's going to come through. So you're collecting for 60 million users all scroll activity. Now, the scroll activity by itself is quite useless for one user, right? I mean, you just scroll past the first entry and you went to the third entry. For one user, it may not be quite useful, but when you start to look at it in aggregate and you start to see the patterns, it starts to suddenly become very valuable. And we've definitive evidence that using A/B testing that this is actually quite useful for us. So what we started embarking on about a year and a half back is systematically collect all the interactive activity from the user, saying, how long did you dwell on the app? How did you scroll? How did you search? Did you hit backspace? Every bit, collect all of that data. And now we're talking about a problem of how do you massage and all of that data and bring value to the algorithm. So that's really context for you guys. So there are clearly a lot of challenges. The biggest one really is, because Netflix is on 1,000-odd devices, how do you collect data that's relatively consistent so you don't have to normalize the data after the fact? So we have to really push some of that complexity to the devices themselves. So by the time it comes into the Hadoop engine, it's somewhat rational and you aren't trying to do joins just to make sense of the data itself. And we're clearly dealing with billions of data points per day. And every one of them is this user saw this box shot and hovered on this for this long and so on. And we have to deal with data quality and data loss, right? And data quality and data loss is at the semantic level because browsers may have network connection issues. We clearly prioritize playback over this kind of data, which is valuable for us, but not as valuable as giving a good playback experience. And because we're on 1,000-odd devices, we have to deal with the fact that the Android Netflix app code base is different than the iOS Netflix app code base. And there may be bugs because people are trying to push code out every other day. So our job as a part of building a data pipeline here is not just to collect and process that data, but we also try and build a mechanism through which we can monitor the data quality in near real time so we can give the feedback loop to the UI team saying something's right or something's not right, okay? So one of the key things that we have to build is validation. So if the user gives if the device sends an impression stream saying the user one saw box shot 1, 2, 3, 4, and he played the title from the fourth box shot, then we have to be able to do some simple assertions. A very simple assertion could be, you couldn't have played the movie if there wasn't an impression associated with that, because you can't just hit play without having seen that box shot. But there are additional complexities associated with that because the impressions can potentially come batched, and it may come 2 minutes after the box shot. So we're starting to deal with event streams that very in a standard way come through Kafka, and you have to join with other event streams that's also coming through Kafka, and the data is potentially offset by time. So you have to kind of group the data, batch the data, and then check for accuracy. So what I'm going to do for the rest of this talk is focus on one use case, which is a recent A/B test that we launched. So an A/B test means not everyone sees it, but 1 million users, for instance, would have been exposed to a new row called trending on Netflix. And assuming we can see key metrics gains, then we start to roll that out to all users. So right now, this is in the phase of A/B testing, but we had to build out a lot of infrastructure around our Lambda architecture in order to be able to support this, even at the 1 million user scale. Because you're collecting data from all 60 million users, but exposing the end user functionality to just 1 million users. So what's trending on Netflix? Apparently interview, when I took the screenshot a couple of weeks back. So out here, what we need to do is the data collection piece is an instance in EC2, and it's taking its data and dropping it into Hive. The standard path is drop it into Kafka and let the data go into Hive. What we need to do is exactly where pull the data off Kafka, en route to Hive, tee the data, and post-process that data. So do some real-time processing, do some batch processing, and then merge the data back after the fact. So let's take that canonical use case. If you wanted to figure out what's trending on Netflix now, you have to do a combination of you have to be able to collect the impression data for, let's say, the last 30 minutes. You have to know all the play data for the last 30 minutes. And you have to do a very simple click-through analysis of all titles. Now, there's a little bit of complexity here in that the impression data, as I said, may be batched, so you don't necessarily get it right away. You may get it 2 minutes after the fact. The devices may have network issues and other such, so we have to deal with complexities like that. But the output is take rates. Its inputs are a bunch of Kafka streams. The output is a newer Kafka stream that you can have other teams consume. At Netflix, a lot of the persistence that we do into a standard data store tends to be into Cassandra. So what we try to do is take that, stream process it in batches of low order number of minutes, summarize that, ship that into a data stream, but also summarize that and drop it into Cassandra, right? And this is the area where we've built a custom processing engine, and we've launched that for the A/B test. But as we go into the possibility that this is going to get productionized, that custom processing just doesn't work. And we have to start dealing with exactly the same things. How do you deal with aggregates? How do you deal with this borderline conditions where you have to make sure to exclude the real-time events from the batch events? And you want to sit on top of something a bit more structured. And at Netflix, we're increasingly inclined towards giving Spark streaming a shot towards this. And part of our motivation is a bunch of the processing that needs to happen in the batch world happens in Hadoop with standard pig jobs and such. Is there any way over the course of the next year or so where we're able to move some of that processing from Hadoop into Spark and then take some of the real-time processing and keep that in Spark as well, so we can try and do our Lambda architecture with Spark streaming, a combination of Spark batch and Spark streaming. So that's roughly where we're thinking of going. So if you look at the trending on Netflix system itself, even that row is not purely what's trending on Netflix, because at the end of the day, if our job is to put in front of you, the user, what's actually likely for you to be playing. So the trending on Netflix row happens to be personalized as well. So what we need to do with our Lambda architecture is basically be able to process impression data and play data, come up with a Cassandra database that has take rates and impressions rollups. Then we have to merge it in with a standard personalized ranker, which takes the entire catalog of, say, 10,000 titles or something, which may be in the US catalog, and then say, that catalog is ranked every day for all users. So we have a personalized catalog. Then we have to say what's trending in the last 30 minutes, and then merge, kind of resort it, re-rank it with a slight degree of personalization. Because what's truly trending may not be quite applicable to you. Because if there's an anime title that's trending in aggregate, But you've told us you really don't like anime. There's no point in putting that in there. So we have to look for some of the user preferences as well. There's another challenge in here, which is, let me see, trying to make Spark and Spark streaming in either of those cases working at Netflix involves challenges around making it work in the context of the cloud. So Netflix, in case you aren't aware, is almost all in AWS. All aspects of the member experience are 100% in AWS. So the challenges that we face are the standard software works when you're in a data center and you can say, take the coordinator node, bring that down. Take this node, bring that down, and functionality should work. Except when we try and do those things in the cloud and you bring one instance down and then a new instance pops back as a replacement, it'll have a new IP address. And if it has a new IP address, the software as it stands now does not quite do all of those. So we've been working with, in the context of Spark, with folks at Databricks, and we've been meticulously fixing the bugs as we find them. And it's gotten to the point where several of those are fixed, and I'm hoping that in the next few months, as we start to productionize and start to scale some of these pieces, we're able to get Spark streaming into production. So I'd say for the trending on Netflix case, it's in pre-production is the right way to characterize the status. Spark in general at Netflix is certainly got lots of legs. And it's used both in the context of batch processing as well as stream processing. My own team happens to run a Spark batch cluster for about 150 nodes or so. And that's, again, to power lots of the algorithmic use cases, which is how do you take search data and you can aggregate it and transform it and then serve that back to algorithmic services that then serve the search experience, for instance. We also have other use cases where, as we talked about the A/B testing piece, the experience you get versus the experience the next person gets is not necessarily the same. So how do you try and do that kind of statistical sampling and other such using Spark is a piece that we've increasingly been utilizing Spark for. So Netflix is 95% a Java shop, but as we start to do more Spark, we're starting to ingest more Scala into our ecosystem. And for lots of the use cases with Spark, almost all the functionality that almost all the ways through which we interact with that data, it happens to be through Scala. Some Python, and Python's probably not quite as performant as the Scala interfaces, but a lot of the use for the Python is with regards to machine learning experts saying, hey, I just want to get access to that data. We're already familiar with Python. There's lots of ML libraries in Python. Great, go to town. And we're able to provide to them IPython notebook with a Spark shell so they can interact with that data, grab the data, and all of that. So that's seeming to work well. And Spark at Netflix, we're running it in a couple of different modes, in standalone mode and inside Mesos as well. So far, there's about at least a small handful of teams with a wide degree of interest, some within the personalization space, some with the A/B testing space, some in terms of traffic management and other such, where they're all interested in dealing with data that we could be using Spark. It's still a long, far away in terms of Netflix as a whole using Spark, because Netflix's data is very much in the large number of petabytes. And so it's Spark's, while there is a lot of interest, it's certainly at the point where there are pockets of community within Netflix that is interested in using it. So in terms of areas of consternation that we're trying to work through with Spark, probably the biggest one is multi-tenancy. If Spark were to work for Netflix in total everywhere, then there's hundreds of consumers of that data, and we can't possibly spin up separate clusters for all of them. And so multi-tenancy is an issue that needs to be solved. But where we stand now, with a handful of teams showing interest, it's certainly manageable to have that many individual clusters and have each of the sub-teams manage operations. And Netflix's culture tends to be lots of people, the engineers tend to do the operations, so it's a DevOps model burnt into the engineering team. So that model seems to scale well for us right now. But if I project a year and a half from now, that model probably won't work if we had 10 times as many Spark clusters, for instance. Tuning jobs has certainly been a challenge, but once we made to work, it seems to be running and seems to be stable. But there's certainly work to be done to make sure optimizing the jobs as such that are running within Spark is reasonable and fast. We're incrementally getting better with scale. There should be an upcoming blog post in about 2 or 3 weeks where we run down our story of Spark resiliency in the context of the cloud. And there should be a blog post a bit after that where we do a first order benchmark with both Spark and Spark streaming as well. Other than that, earlier today, coincidentally, we had a more detailed blog post about the trending on Netflix row and how exactly we use Kafka and referencing how we built our version of this Lambda architecture. So feel free to go read about it. It's techblog.netflix.com. Yeah, we're hiring as well. So you should talk to me. Everyone's hiring all the time. So if you had questions, feel free to tweet me or just talk to me later today, and I'd be happy to answer any questions. With that, any questions for right now? Yeah.
So you mentioned that you are using Mesos.
Yeah.
Did you compare that with Yarn and other things like?
There is certainly a group that's evaluating Yarn as well. In the context of lots of the use cases that we're dealing with right now, Mesos seems to be functional, and so we've gone with it. They're not large enough use cases for us to have done a very complete evaluative study.
So what other loads besides Spark you were testing Mesos with? So MapReduce or something other than that?
MapReduce mostly, yeah.
You spent some time about talking about sort of implicit preference, identifying preferences implicitly. What about identifying users implicitly, in the sense that inside of a given household you might have 2 or 3 users?
Yes.
Is there anything going on with that?
So absolutely, when the user gives us data, which is in my account, there's a bit of Pokemon and there's a bit of Bollywood, we already know that we can take all the users' play activity. So take a user's complete play activity, and then we will be able to assign that user to clusters. And in the process of assigning the user to clusters, we don't do a hard, hey, you belong to this one cluster. So the user can be soft assigned to multiple clusters, for instance. So I may get assigned to a kids cluster, a Bollywood cluster, and an anime cluster, for all we know. And that's roughly the equivalent of trying to identify not necessarily who the user is, but what his interests are. Because even I, the user, may drop in front of my Netflix app at 3 times a day, and I may be in completely 3 different modes.
And my second question is, do you ever run into challenges in terms of selecting partitioning keys for your streaming data, in terms of ensuring that you achieve a satisfactory level of parallelism, but you don't run into an issue where the relative ordering of events could create a problem for your downstream analytics?
Yeah. Lots of the data for us, we tend to order it by user, user device class combinations, etc. So that seems to work reasonably well enough for us. Lots of the event streams is very typically by user. Mm-hmm. There are some use cases, actually come to think of it, where we don't necessarily have, beyond just given a user what did he see, we may need to be able to tell, given a video, how many people saw it in the last 15 minutes and how many people played it within that, and give a take rate by video. Mm. So you look at that particular use case and you have to figure out what's your key. But downstream in the standard Hive area, it tends to be a lot pretty much by user.
Thank you.
Have you looked at differences based on the medium or like a tablet, smartphone, if the viewing preferences changes just because you're using a certain mode of delivery?
Viewing preferences? So we certainly know that if you picked up a device that you've used before, we certainly have a signal that says, odds are it's you. Because odds are the person in front of the Wii is your kid. So we can tell that. So there's certainly the device on which you use is certainly a signal into our personalization story. So when we record the play, not only do we record what's the user ID and the fact that you played title X, but we also record which device, which specific PS3 in your home did you use. We can record that too.
Aren't there on some OSs you're doing right now where you're actually picking a profile though, like on the, PS? So that definitely gets explicit, and then that isn't as much of an issue.
Yeah, exactly. So the challenge with profiles is that not everyone has profiles yet, right? There's incredible adoption, but at the end of the day, we still have to deal with a user being in multiple modes over his subscription cycle.
In terms of the UI events, you said billions per day. How much of that is actually, meaningful when it comes to making a recommendation? How much of it is throwaway?
Yeah. So a fair fraction of that is impression events and during playback. So let me add 2 parts. Impression events is a very large quantity. Playback heartbeat events is a very large quantity. And both have their own reasons and why they are critical. Let's start with the more critical one, which is playback heartbeats. So we send heartbeats back from the device to our control plane probably every, 10 seconds, 20 seconds, something like that. And the reason for that is not only for the device to tell us, hey, I've also played an additional 10 seconds, which helps us with bookmarks, but we're also essentially doing adaptive streaming. So we're sending payloads back to say, this is roughly my network topology as I observe from my home. Is there a better spot for you to pick your next 15 seconds of the video, right? So there is a lot of that, and that's used in relatively short cycles. And the impression data, it's very clearly useful, and probably useful because we've had A/B tests that use that and don't use that, and using it clearly helps with our personalization. Because without that visibility, it'll be like Google saying, here's your search results, and re-ranking the search results every day without knowing your browser window size. Did you see 10 results or 5 results? Well, I don't know. We were running blind that same way about probably a year back, a year and a half back. And I think having that visibility has been useful. We certainly work a lot on compacting that data. So devices don't necessarily send 1 billion packets per day because we can compress that data, and on the server we can blow it back up into distinct events. So when we're processing in Kafka, there are 1 billion events, but we clearly optimize at the network transport level.
So does your recommendation have a time component, like hour of the day and stuff? Like at what time somebody is
absolutely
taking action?
There's probably about 700 different signals that go into that. And this is the challenge with building a runtime model, where if you needed to get all the 700 features in, fetch the data from the 300 microservices, and then assemble the data, that'll take 12 seconds. So what we try and do is, as many aspects as possible, try and do pre-compute. But the time of day, you can't pre-compute that. Or there are actual ways through which we can cheat it, because we don't need to compute separate recommendations for 4 p.m. versus 5 p.m. We just need to say, if it's 3 p.m. school day afternoon, we can take a good guess who's in front of the TV versus 11 p.m. who's in front of your laptop, right? So we can take that broad guess, but certainly it is an aspect.
Any other questions?
You spent some time talking about Spark. Is Netflix in the face of transitioning from traditional Hadoop job to Spark, or what's your take on that?
That would be a way overstatement. I would say our interest with Spark is in pockets. Netflix is very much tied with Hadoop for the petabytes of data that we deal with. What we see is when pockets of the organization need to run much faster than, I don't need that scale, I don't need that stability quite yet, but I want a lot more flexibility. And that's a handful of pockets. Like say in some of the nearby teams that I deal with, we're dealing with algorithms. We need a lot of native support for speed of retrieval of data. We need better native integration with machine learning libraries and other such. That's when we start to say, oh, Spark's useful there. We should experiment there. We should see where it goes in about a year, and then we'll see, right? But it's certainly very isolated pockets.
Any other questions? All right, thanks, Gopal.
All right,
Excellent.
thank you.